So, a lot of developments have been taking place in the space dimension in recent times. You might have come across news of the two NASA astronauts, Sunita Williams and Barry Wilmore, who have been unfortunately stuck in space, and it will not be before 2025 that they would be able to come to Earth. And what we are going to discuss today is not only what is happening in the news, you all know that. We are also going to discuss some of the concepts of why it is happening, what has happened. And moreover, there are so many developments which have been taking place that it was very difficult for me to collate and combine the various dimensions. So I try to make a structured presentation so that we go step by step. So, for example, we are going to discuss first what is happening, what are the symptoms that the astronauts might or have been facing. Then we are going to discuss who are the new players like SpaceX of Elon Musk, the Soyuz rocket, which had the monopoly over the space sector for the last 8 years. What happened to the NASA space shuttle? Okay, it was retired. The Boeing Starliner. Then we'll move on to the various orbits, the basics like what are the geostationary orbits, the telecommunication satellites, and of course, I cannot help but discuss about the pride of India, that is the Indian Space Research Organization, and we are going to discuss some of the major phenomenal developments which have taken place. And finally, to add the cherry on the cake, we are going to discuss some recent findings of Chandrayaan about the Pragyan rover under the Vikram lander. So, what do we understand by the International Space Station? In basic terms, it is a football sized space observatory, floating space observatory. So, it is used to conduct research majorly in the space, and time and again, the astronauts make a visit pay a visit for carrying out research works, and not only research works but also repair works as well. They conduct space walks, so various different exercises are done. So the interesting part now, you know what is an orbit. This orbit term will be used. It is basically a fixed path in which a satellite revolves around a body under the gravitation, under the massive greater larger bodies gravitational influence. So it also revolves around the Earth, the ISS. So the interesting point is it revolves at such a pace that it makes one complete 360-degree round around the Earth in 90 minutes. So that if we calculate multiplying 90 into 60 divided by 24. So in one day it comes out to be 16 revolutions around the Earth per day. So this is an interesting fact I just wanted to share with you. And moreover, the astronauts, they are normally sent in groups of three. NASA hosts an average of six scientists at a time at the International Space Station. And moreover, they stay for 6 months, they go in cruise of three, and sometimes there is an overlap of time. So there is a basic. So we are going to discuss basically two important topics. This is the astronauts stuck in space and our very own ISRO, the Indian Space Research Organization, along with some very interesting, scintillating topics. Okay. So, what is the Starliner? Basically, what happens when any space project or any spacecraft is launched, the spacecraft or the capsule in which the astronauts, in which the payloads, or in which the satellites are carried, it cannot directly go into space because in order to launch into space, powerful rockets with great immense thrust and power are required. We'll discuss brief about the components of a rocket, the spacecraft. So the basic idea is we need a powerful rocket, a powerful device on top of which normally a crew module or a service module is placed, which is taken to the orbit. Various stages are present in the rocket. Various thrusters are found are there, and with every ascent, with every particular ascent, which is calculated by the scientists, so the thrusters they fall off in pieces, and then the the service module, the satellites is launched and it starts orbiting the space. So what happened was in 2011, NASA retired its space shuttle program. You might have heard about the Columbia space shuttle, the Challenger space shuttle. So we are going to discuss, don't worry, we are going to discuss in the next slide also. So what due to several reasons it was cancelled. So new private players, most more cost effective players, private players, companies, they have emerged in the market. Same with the ISRO also. You might have heard of the New Space India Limited. So in case of the NASA, this it invited applications from major players, of which the Boeing and the SpaceX applications were accepted. So the Boeing, again, there are two major components in any project. So one is the rocket and one is the satellite. So Boeing, the rocket is known as Atlas, and the spacecraft in which the astronauts and the payloads travel, that is known as the Starliner. In case of SpaceX, Elon Musk's SpaceX, the rocket that is supposed to be launched is Falcon 9, and the crew module or the service module atop on it is known as Crew Dragon. Okay, so that is it is a space for commercial purposes. And now, what is the main prop? So it looks like this: the Boeing Starliner. So this is basically there is a rocket. In Boeing's case, it is Atlas, and this is on top of it. I'll show you the actual images also in the following slides. Now, what is the problem? Why the astronauts are stuck in space? Because in space, now only this module is left. The rocket, which was used to provide the thrust and escape the Earth's gravity and put it into the orbit, it it has docked. It has completed. It docked with the International Space Station. Now to come back, it has to use its own thrusters, which are powered by helium. Okay, so during the thrust during the space descent, it's not that it will direct, it has a fixed it has a trajectory, but it is not that it is just going to undock from the International Space Station and just start dropping towards the earth. No, it has to be maneuvered. There is specific eccentricity, there has to be a specific angle at which the Starliner or the spacecraft has to enter the Earth's atmosphere, or else disaster might happen. It may burn uh, due to failure of heat shields. So this maneuvering is very important. So this failure, this helium leaks have been occurring. So this is the major issue why the astronauts have been stranded in space. Now, some interesting things, although they are unwarranted things, which happen in space. So these are the two astronauts. So first of all, this is very interesting. I read a little more about it. So first of all, weightlessness, there is microgravity, negligible gravity in space. So what happens to scientists if they stay for a prolonged period of time? Because we people, when we go to space, we are actually accustomed to the Earth's gravity. So when the humans experience microgravity or weightlessness in space, so the bone density and the muscle strength that decreases. You might have heard of a term muscle atrophy. So that bone density decreases. And moreover, when bones start disintegrating, they release calcium as well, and that may cause kidney stones in astronauts as well. And moreover, when they return from space after a long time, it takes a long time to rehabilitate those bones, to rehabilitate those muscles, to get back that original strength. So you can imagine the situation. Second, vision was much in news. Sunita Williams is probably facing from vision problems. Now what happens is, gravity on earth, it maintains all the balance, entire balance, the rotation of various fluids in the entire body. Now now gravity is responsible for holding the fluid under the influence of the its force. Now what happens in weightlessness or the microgravity, due to absence of the force pulling downwards, the cerebrospinal fluids and the bodily fluids, they travel to the upper part, the torso, and towards the head. So the enlargement and the engorging of those upper parts, so it makes the brain swell, so it makes the sheath of the optic nerve. Also, it puts pressure on the sheath of the optic nerve. It puts pressure on the pituitary gland. So due to this, the sight is greatly affected due to the pushing, the excess pressure on the optic nerve. So this is one reason. Then because of the redistribution or the haphazard distribution of the fluids, the red blood cells, production of red blood cells and hemoglobin is also adversely affected. So there is a concept known as space anemia. And finally, we know that even though we have great advancements and technological developments in the field of uh, development of spacecraft, but still there are cosmic rays, there are solar flares, solar winds, which can penetrate through the external hull, the external structure of the spacecraft, and it can enter or it can proliferate the humans, the astronauts' body and cause DNA damage, in turn relating to adverse consequences such as cancer. So this is what, so astronauts, they go rigorous training and they have to take proper diet and cardiovascular exercises aboard the International Space Station also, so that the adverse effects or the negative effects, harmful effects can be minimized. So this is what is there. Okay, now the interesting part, we'll discuss the various important rockets, the companies and their respective rockets and spacecraft. So majorly I have been telling in the initial, from the initial part of the presentation, that there are two major parts in any space project. So one is the rocket and one is the space module or the spacecraft, the service module. So this is the rocket which will propel or carry. It will help the spacecraft to escape the Earth's gravity. Okay, so this is the Atlas V rocket, and aboard this is the Starliner spacecraft in which the two astronauts, Sunita Williams and Barry Wilmore, are stuck. Okay, this is under the company Boeing. This is SpaceX, Elon Musk's company. So its rocket is known as the Falcon 9, and its spacecraft is known as the Crew Dragon. So it is, it has been in the news that it is going to be launched to get the two astronauts back from space, and this is one of the more prolific rockets. This is the Soyuz capsule and the Soyuz rocket. It is under Russia. Basically, it has been functioning in place during the Soviet Union, from the times of the Soviet Union from 1960s. So I have just put Putin's image just to give it a reference. And this NASA. So this NASA, you can see this is the Challenger spacecraft. This is not the rocket. This is a spacecraft, and the rocket, this brown part. You can see brown part rocket. This is the major thrust propelling engine, and aboard that space shuttle is attached, which has been retired in 2011. Okay, so this is basically, I think you have got the gist of it. Okay, now some interesting points. So apparently, once I have told you, so if movies, you might have seen movies or TV shows, so you might have seen this is like, so this you can see small structure here. So this actually is the service capsule which is returning to Earth. So obviously, we know the rocket has disintegrated into debris, and now after its journey to whether ISS or the moon or any space expedition, so when it has entered, so obviously under the space of gravity, under the force of gravity, it has high speeds. It has to slow down. So parachutes are deployed, various systems are there, and finally it has to land. So it was planned that the Starliner spacecraft was to has majorly two areas. There are several areas in which it has to land. It cannot just land in the middle of the street and cause chaos or attract crowd attention. So there is the White Sands missile range in New Mexico where the spacecraft can land. And after entering Earth from space, and there is the Dugway Proving Ground in Utah province, Utah state of US, where they can land. So this is the landing. So apart from the landing on the land surface, the landing can also take place in the ocean. So this is specifically related to the landing of the Crew Dragon craft of SpaceX, Elon Musk's company. So, unlike the Starliner, which has been designed to land on the land surface, the Crew Dragon spacecraft or service module, not the rocket, I am repeating, it is designed to land on the water, and then it is extracted by the rescue boats to evacuate the astronauts and so forth. And this major site, you might have heard, this Cape Canaveral. Okay, Cape is a geographical feature, portion of the land jutting out into the sea, and Canaveral is the base, so it is a site of the for the Kennedy Space Center also, and it is one of the major rocket launching sites for the NASA astronauts. Okay, now special thing, now interesting concept. Just it is interesting, so just try to understand that you might have seen that most of the rocket launching spaceports or rocket launching centers like Cape Canaveral or Sriharikota, Satish Dhawan Space Center near on the coastal Andhra Pradesh, and the recently opened spaceport, the Kulasekarapattinam in Tamil Nadu. They are situated near the equator. Why is that so? Okay, first of all, we have to understand what it takes to go into the orbit. So, if I take the help of the image, so suppose this is our Earth. Okay, now if I stand on this tower, and I drop a ball, I throw it in a forward direction, so it will, after some time, it will drop to the ground. Okay, if I increase the speed, then it will increase a larger distance. Now, my target is to make this ball, consider it synonymous with a satellite. I want this ball or satellite to rotate around the Earth. So not only do I have to launch it from a greater height, but also with sufficient thrust. So for that, I need I need a bigger tower, and I am going to launch it with such a speed so it starts rotating in an orbit, conducting revolutions around the Earth. Okay. So two things are required. One is, so obviously such a high tower cannot be created, so we need rockets. So rocket will propel it towards the space through its powerful thrusters. That is what is required to escape the Earth's gravity. But again, it has a trajectory and it is a curved part, because after it encounters, after it has escaped the major portion of the Earth's gravity, it has escaped the atmosphere, the air drag, the air friction. Now, if it is allowed to go straight into space, so it will escape the Earth's gravity entirely and it will be lost. So, again, it will be not in orbit. So, it has to be under the influence of Earth's gravity in such a way that it does not fall down and it does not go into the outer space and get lost. So it is first propelled, and via thrusters and maneuvering, it is given a sideways push, and in such a way it starts orbiting. So we'll not go into much detail. So this is how it works. So till recently, what was happening before the immense developments in the Polar Satellite Launch Vehicle PSLV, which is the workhorse of the this Indian Space Research Organization. So we were dependent upon the foreign space vehicles. Most commonly, you might have come across this name, the Ariane space vehicle. This is a group of space vehicles owned by the European Space Organization, European Space Agency. So there they have various centers, various spaceports, and one common spaceport is Kourou in French Guiana, which is not in Europe. It is in South America. It is an overseas territory of France. So our satellites used to be launched from there. Okay. So now we have accomplished so great achievements in India that we are now carrying other countries' satellites We are making them piggyback on our PSLV and launching them into space. Okay, so we were talking about the equator part, that most of the this Shar and this Kulasekarapattinam, they are near the equator. Okay, even this we were talking about the Florida. Okay, the on the western. So these are near the equator. Why? Because in order to take the help of the high speed of the equator from the inertia. Now, what I'm trying to say is a person standing on the equator will have a greater speed of rotation as compared to the person standing here. First of all, we all know the concept of longitudes. So, in longitudes, basically, what we see is that at a particular longitude, the people we observe the same time. Okay, so it will be 12 noon at point A on this longitude, so there will be same time at point B as well. Now, in one day, it has to this person has to cover this whole periphery, this whole equatorial circumference in order to reach here. And in same one day, this person A has to rotate a smaller distance, but the time is same. So applying the mathematical concept, speed is equal to distance upon time. So time is same, but distance is more. So since this guy B has to travel a greater distance in the same amount of time, so its speed will be higher. So in order to launch, because the GSLV, the geosynchronous launch vehicles, which are used to put communication satellites in space, they are supposed to be in the plane launched. They are supposed to be launched in the plane of the equator. They rotate like this, revolve like this. So it this excess velocity help these thrusters to conserve fuel, to provide additional force to inertia. Just consider it that when we are traveling in car, so we are traveling at the same position, same speed as the car. So similar to this. Okay, so I hope you got the concept. This was an important concept. Okay, so coming back to this. Okay, so different types of orbits. We'll go through this quickly. So first of all, we have already discussed about this. Okay, so different types of orbit. Geostationary orbit. So geostationary orbit, by the name, what it means is that the satellite, which is, for example, if this is a satellite in space, so if it is in a geostationary orbit, it will appear to be relatively fixed in a particular place with relation to Earth. So we'll at any one point, if we observe the satellite, it will appear at the same fixed position. So different orbits have different roles. So the feature of this geo satellite is that it it has a distance from the Earth. It has a radius or distance from the Earth of around 36,000 kilometers, and it revolves in one sidereal day in 24 hours, and after rotating it rotates along with the earth at a speed of around 3 kilometers per second. And how it is useful? It is useful for communication satellites placing high in the orbit. Why? Because we know that for the point of from the perspective of the communication satellites, a satellite has to be appear fixed at a particular time. So three satellites can be put in conjunction with each other, having having an angular distance of 120 degrees to cover the entire Earth. If it is not geostationary, if it is moving at a different pace, if at one point it is here and then this point, this point recedes or this point moves ahead of the satellite, then the continuous monitoring of the antenna cannot take place. Okay. Then next we have the low Earth orbit. So as you can see from the name low Earth, so it is at an altitude as less than 2000 kilometers and more than 160 kilometers if we consider airplanes, they maximum altitude if we consider flying, so we can say at 20 or 30 kilometers. So since that is lot, so this why this is important, is significant from this presentation's point of view, is because of the International Space Station. So it revolves in the low Earth orbit. Then we have medium Earth orbit, just significant feature. So it lies in between, the altitude or the radius lies in between the low Earth orbit and the geostationary or geosynchronous Earth orbit. So here it is used for navigation system. So this is an illustration of the Galileo system of satellites, which provides navigation to the countries, to the citizens of Europe. Just like GPS is there for US and India also uses. Fine. Okay, so three more important orbits which we need to. So this is SSO, the Sun Synchronous Orbit. It is a type of polar orbit. So polar orbit, when we consider, what do we what do we mean by that? So it is counter to the geostationary orbit. So in that we have in geostationary, we know that it is rotating or revolving around the in the equatorial plane. In case of geostationary orbit, it is revolving from pole to pole. So just imagine a satellite, it is coming in front and going behind the board. So how this is important, and it is placed in region of the low Earth orbit, this sun synchronous. Now why it is synchronous? Because it appears over a particular point at the same time every day. So for example, so if here it is noon, so its satellite is above here, so it will make a revolution. We know the polar satellite is there, revolving in the sun synchronous orbit. So when again next day the noon will take place here, so it will be at the same point. So it helps in maintaining the amount of light falling at this particular place. So what will happen is, it will help in the constant uniform monitoring of particular events, like we see the before and after changes, sea level rise, forest fires, weather patterns. So if the light falling on a particular point on the earth is same, and the satellite gets the chance to record that uniform with the help of uniform light to see the pattern changes. Okay, geo transfer orbit. So in this, the main feature is, what happens is, this the thruster, the rocket goes till this orbit, then this is blue line is the geo transfer orbit. It is like a shortcut. So in order, if in case the power required for the rocket is not sufficient to put it in the final orbit, so geo transfer orbit is there. So this satellite is launched in this orbit, this elliptical orbit, and finally it is, by its own thrusters, it starts. This is the perigee, this is the apogee, the farthest point, and it starts revolving around the earth. And this is of recent importance, very important from the point of view of the James Webb telescope or the India's Aditya L1 sun mission. So sometimes what happens is, in order to study the sun or study the distant galaxies. So if we place an satellite in the orbit of the Earth itself, it radiates various wavelengths of light, uh, the visible wavelengths of light, the infrared wavelengths of light, so it will interfere in the imaging quality. Just imagine that if we the best time to observe galaxies or stars is during the night by the observatories situated on the surface of the Earth. So we these are L1 and L2 are the Lagrange points. So in order for these Aditya L1 James Webb telescopes to observe distant galaxies, we place it at a distance at which it appears to be anchored. So it is under the influence of the gravity of the sun and that of the earth. So it revolves. So if this is the earth, so it is launched, the satellite is launched here, and this at L2, if this is the point L2, it starts revolving around this, and it is at a sufficient distance from the Earth so that the light emitted from the Earth, reflected from the Earth, it does not interfere with the imaging, and uh, it can observe and image the faraway galaxies. So this is the point of the Lagrange points. Now finally we come to ISRO, India's pride. We'll quickly discuss the major rockets that we have. So first of all, PSLV. The first we had the SLV simply. Then we have ASLV, had ASLV in the 1990s, Augmented Satellite Launch Vehicle, and in 1994. So this PSLV, like we said, Polar Satellite Launch Vehicle. So majorly it is for the polar orbits. So in the LEO, sub GTO and the GTO, but it is the major. So most of the satellites, it is used for weather observation. So the low orbit Earth orbit satellites, the PSLV is the most commonly used orbits. Now these are the more powerful rockets. This is LVM. Now it is also known as the GSLV, Geosynchronous Satellite Launch Vehicle. This MK3, this is MK2, MK3. So this is the launch vehicle aboard which the Chandrayaan 3 was taken into the space. This is very important. So this can, more powerful the rocket, higher the capacity or higher the weight of the satellite that the rocket can. So there is a trade-off between the radius or the distance and the weight of the satellite, the distance from the Earth, the orbit. And now recently this SSLV, Small Satellite Launch Vehicle, because there are a lot of commercial players, both small and big. So this NSIL, New Space India Limited, is created as a commercial arm. So because PSLV, although it is the workhorse of the ISRO, but it takes a long amount of time to build it. And if a satellite has to be launched quickly at a lower turnaround time, so we have to has to develop a uh, less powerful rocket so it can be easily created and launch the satellites into space. This is just the differences, how much category. So obviously, the more powerful LMV, it can take 4 ton or 4,000 kilogram class satellites to GTO and 10 tons to LEO. So obviously, higher weight satellite to a lower orbit or a lower weight satellite to a higher orbit. And this is the more interesting part. So this is the recent, it was recently in the news. So this Kulasekarapattinam, we had discussed this Sri Harikota of the coast. This is the SHAR, Satish Dhawan Space Center, where majority of the launches have been taking place. So this Kulasekarapattinam, a spaceport, has recently been developed. So it is not only it is closer to the equator, but also it provides a uniform trajectory, because what happens is normally, apart from being near the equator, the spaceports are also located near the coastal region. So if example, instance, if unfortunately the rocket fails or some debris fall from the rocket, so they don't fall on the populated areas where the citizens reside, they instead fall into the oceans safe. So when This PSLV was used to launch a GSLV from this. So you can see it cannot go south directly because Sri Lanka lies in the way. So it has to take a curved eastward trajectory and again go south. Why south? We are talking about the polar satellite launch vehicle here. But in Kulasekarapattinam in the Tuticorin or the Thoothukudi district in Tamil Nadu, it does not have such a hindrance. Okay. And finally, the cherry on the cake. So Chandrayaan 3. So this alpha particle X-ray spectrometer. So there are some techniques in which the particles, like alpha particle, is basically a charged helium nucleus. It is a helium nucleus. So helium, two protons, two neutrons. So helium atom devoid of the two electrons in that. So they are bounced on the particle on the surface, and then the reflection which they are studied. Just a concept. So the terrain around Chandrayaan 3's landing near the South Pole is fairly uniform. Then it supports the lunar magma ocean hypothesis that the crust of the moon, it is formed in layers of magma. Okay, and the top side or soil had greater than expected sprinkling of minerals. So just some facts that this Pragyan rover, this is the lunar lander, and the rover, it was detached or released from this. So this is the Pragyan rover. So these findings are going on, and this have been recently received by ISRO. So this was majorly about what the space developments. I think a lot of information has been thrown at you, but it had to be compiled in a concise time because greater the I want you to make the best use, even if you it's not obviously when people view the videos, I get more views, it is more encouraging, but again the duration of the view is also important because I want all the people, whether students or whether layman or general citizens, to gain maximum from what I am preparing. So with that, stay tuned till we meet next time. Jai Hind.